So, okay, good evening. Okay, let me share my screen. Can you see my screen?
Yes, sir.
Okay. Now, so today we are going to discuss so what is orchestration tool. Already you know, right? Containerization part Docker. I hope already Docker is completed, right?
Yes, sir. Completed, sir.
So what is Docker and so what is the so how to create so our own images and how to create containers.
Yes,
So
sir.
now you have some idea.
Yes, sir.
Okay. Okay. So now with the help of Docker, you know, right? So we can create images, our own images, and so we can create containers, correct?
Yes,
And
sir.
also,
Yes, sir.
so within this container, so you know, right? So we can deploy your application. So under the container, your application is running, and how to access and how to set the port numbers and all, you know, some basic. Suppose you created one container. Yes.
Okay. Yes, sir.
So this is the one container. Just already know this is the Tomcat container.
Yes, sir.
So this is the Tomcat container. So this is the so Tom. What is this? So this is the Tomcat container, and so unfortunately, so my container was crashed, or my container was someone is deleted. Okay. So now how
Okay.
to? What about our application? How can you access your container? Is it working or not working?
Not working.
So
Yes.
this is the container. Only one container is created and everything working fine. So everything working fine. So unfortunately your container deleted or it is crashed. Okay. Now can you able to access your application?
No, sir.
Can you able to access your application? No. So obviously usually we cannot access, right?
Yes, sir.
Someone is joined. Wait, let me add this. So now we cannot access. Correct. So default font size 18. I don't know why it is. So this is our application. So we cannot access. If container is running, if everything working fine, we can access it. So unfortunately, your containers crash or it is deleted, someone is deleted. Now your application goes down, right? We cannot access. But how to overcome this scenario? But every time we cannot run manually, right? If we come to real-time scenario, suppose if you want to manage, if you want to configure. So in single day, we are going to deploy multiple times. Correct. We are pushing many changes, we are creating and we are deploying it. So without application downtime. In this case, obviously it is downtime, right? If it is
Yes, sir.
crashed or it is deleted or it is not work, something goes wrong, my request go to only one container. We cannot access your application. So there is some drawback, right? Now how to overcome this? So if you want to overcome this, so there is a new tool. This in market also. This is the topmost tool, orchestration tool. So what is the orchestration tool? This is the K8s. Simply we are calling K8s. So what is the full name? Kubernetes. What is the full
Kubernetes.
name? Kubernetes. Someone is calling, you know, right? So K8s and so someone is calling Kubernetes. So both are same only. Don't confuse here. So already while discussing, so Docker, already sir given some idea how it will work, what is Docker architecture, and what is the main components in Docker and how it will work. Now, so if you go here, there is Docker. Now, if you go here, so Docker means, you know, right, this is your existing host mission. This is your operating system. On top
Yes.
of operating system, we are going to install Docker.
Docker.
So with the help of Docker, we can create multiple containers, right? We can create how it will work already, you know. So some basic idea and all. Now there is a C here, Kubernetes and Docker work with together to build and run containerized applications. Now, if you observe here, so as of now, only we are installing one Docker. On top of we are going to create multiple containers. Now, what we are going to learn? There is Kubernetes. What Kubernetes is? If you see this diagram, so what you understand? We can handle multiple Dockers, multiple machines, multiple containers. Now, got it? So as of now, you know how to install one Docker, one mission, and how to deploy, how to create image, how to create containers, how to access and all. Now, if you want to handle multiple Docker machines, now we would go for what is the Kubernetes orchestration
Kubernetes.
tool. Now, Kubernetes have this many facility. There is lot of features available, and Kubernetes has capability to handle multiple Dockers also. And interview and real time also, nowadays most of the people in interview also, most of the people they are asking only Docker and Kubernetes and Ansible or any configuration tool. So now already you know Docker. Now slowly we are going to learn so how to play with Kubernetes and what is the Kubernetes advantages and what is the Kubernetes architecture and how it will work. Now if you go to here, right, Docker. So in Docker there is a, what are the main components in Docker? What are the main components in Docker? Or Sudhir? So this is the official website, right? If you go here,
Yes,
if you
sir.
go here, so these are the main, right? So this is the Docker client, Docker
Client,
daemon,
daemon,
images,
images contain
containers,
registry.
registries. These are the main components. This is the Docker architecture and how it will work. And these are the main components in Docker. And same way, if you come to Kubernetes, same way if you come to Kubernetes also it is following some architecture, and so mostly Kubernetes is following master and worker node architecture. What is this? It is following master and worker node
Working.
architecture. Now, if you go here, so this is my Kubernetes master. So this is the Kubernetes. Here we are going to create multiple worker nodes. This is a new terminology. So try to understand. Slowly we can understand how it will work. So this is the master. So this is the Kubernetes master, and so it is following master and worker node architecture. Now if we see here, so this is the master. Now this master can handle multiple worker nodes. This master can handle multiple worker nodes. Now got it? Now here also there is main components. This is the master, Kubernetes master. This is also one server, but it is there we are going to do some extra features. We are setting some extra features only. That's it. This is the Kubernetes master. This is the Kubernetes master, and these are the nodes, worker nodes or node 1. This is the node 1, and this is the node 2, and this is the node 2, and this is the node 3. So like this we can handle, we can create, we can configure multiple nodes. Here, now got it.
Yeah.
Okay.
Yes, sir.
Now interview also many people they are asking what is Kubernetes, and so why we should go for Kubernetes and what are the features of Kubernetes. So most of the people so they are asking. So these are the interview questions. So mostly they are asking Kubernetes class. Okay. I will share this. Now see here, first we'll see what is Kubernetes and what is the advantage of Kubernetes and what is Kubernetes architecture and components, what is the cluster setup and how it will work, what is the cluster setup and how it will work, we can understand slowly. So this is very very important. This is very very important, and so slowly we'll see one by one. See, now if you go here, so in intro also most just remember one or two lines. What is Kubernetes? See here, Kubernetes is an orchestration engine. Docker is a tool, right? Docker is a tool. With the help of Docker, we can deploy application. Right? How it will work. Now, if you see here, already what is Docker and how it will work. Docker architecture. Docker is a open source platform for developing, shipping, and running an application with containerization. Now got it? Same way. What is this Kubernetes? Kubernetes is an orchestration engine. This is an orchestration engine, and also this is the open source platform. So almost in right. So DevOps tools all are open source. I hope everyone know. So are you paying anything? Are you paying any buying anything? No, right? So this is also open source platform for mapping containerized applications. So what we want to go into implement? Containerization, Docker. Okay, and it is responsible including container deployment, and we can easily scale up and we can easily scale down containers, and also we can configure load balancer. So now if you see here, so if you go here Docker, if you go here Docker, so if you I created one container, so this is the one container, so I created one container, I created one container, and so if you create if you want to increase this container, so same setup, same can you increase, or we can create one more container. This is the one container. How it is working? This is the one container. Suppose if you need one more container, is there can you scale up same container in Docker? Can you scale up same container? For example, I need 3 containers or I need 4 containers. Is it possible in Docker or Dharani? Clear, Sudhir? This is one
Not
container.
possible.
We created one container. Okay, so now I want to increase. Now, if you want to increase same container, is it possible? Did you try this one? No, right? Yes or no? Now, if you go to Kubernetes, if you go to Kubernetes, so we can easily scale up and we can easily scale down. We can easily scale up and we can easily scale down. We can easily scale up and we can scale down. How many containers you want? So this is here is nothing but there is a pod. So here terminology is there is a one pod Kubernetes, and each pod inside a pod. So there is one container. So that is the here terminology is pod. We'll see what is pod and all and how it will work slowly. Now if you go here, see here responsibilities including container. You can easily scale up. How many containers you want? Okay, if you want to, we can scale up, or if you want to, we can scale down. And Kubernetes is not a replacement of Docker. Okay, but Kubernetes can consider as a replacement of Docker Swarm. Right? So as of now, Docker. There is one more concept also is the Docker Swarm. This is same RM Swarm. But anyway, here we are going to learn Kubernetes, right? So that is the reason. So mostly this is the deprecated. Nowadays, most of the people, no one is using Docker Swarm, and so here also same concept, but there is limited features in Docker Swarm. So that is the reason we are not going to mostly focus on Docker Swarm. Mostly we are focusing on so Kubernetes. What is Docker Swarm? If you see here, now we can see this is also same. Docker Swarm is a group of either physical or virtual machines that is running on Docker applications that have been configured to join together in cluster. This is same like Kubernetes only, but there is only limited features. We don't have many features. We don't have many features. This is like same virtual or physical. Here is the here also same. Here also same. Here also same. Master and cluster architecture it is following, and there is limited features. We don't have many features here. If you want to go through here, if anyone, how it will work and all, and so this is the compared to Docker Swarm. This is the Kubernetes advanced one. So if you know Kubernetes, no need to focus on Docker Swarm. Just what is what if you want to can go through it. See here. So Kubernetes actually it is not a replacement of Docker. So it is the replacement of which one? Docker Swarm. So Docker Swarm also like it is right same concept. It is also following same concept, but here we have many only limited features. We don't have many features. Clear, Srinath? Clear? Anyone? Any
Ah,
doubt
yeah,
here?
clear.
Okay. Now see here. These are some basic points. And see here, it is born. So who developed Kubernetes? Google. And which year? 2014. And it is written in Go language and donated by Cloud Native Computing Foundation. This is one organization, CNCF. cloud native computing foundation. This and all, no one is asking interview. No need to worry. For your understanding, just learn. So first version they released, so version 1.0. Now what is the current version? I think 1.27. Now if you see Google it, so Kubernetes current version, K8s current version. I think so. This is the 1.27 or 28 also is there. See here 1.2. This is the latest version. See here the Kubernetes project also maintain release branches for most recent three major releases 1.28, 1.27, 1.26 and 1.19. So this is new approximately. So we can use anyone. We can use anyone. Okay, coming out and this is released 1.24 also released. These are the latest versions. So see here the first Kubernetes release 22 will be released on so May 3rd, and right now this is the latest version 1.28. Interview also they are asking which Kubernetes version we are using. Don't tell highest version, at least give lower version. Now we can say 1.24. Now we can say 1.24. Don't tell 1.28. So in real time 99% we are not going to use, we are not going to work with latest version. Latest version means recently they released, so there is some problems, there is some issues, so that is the reason. So 99% we are not going to work with latest version in real time. Now got it? Just give so lower version, bit lower version. Not only this one, any version if they are asking, even Java which version we are using, don't say so Java 17 latest version, there is a latest version also available, right? So don't give any latest version, just give a bit lower version only if they are anyone is asking. Clear, so there, I hope you got it right. Yes or no? Hello.
Yeah, yeah, yes.
Okay. Now see here, this is the current stable version 1.8. Actually, this is the old document. Now what is the, so this is the stable version 1.24 or 1.19 also, that is already out. Now we can say 1.24. This is the old, right? That time 1.8. Now see here, these are the Kubernetes features, guys. Please remember three to four points. Interview also most of the people they are asking. So what is Kubernetes? If someone is asking what is Kubernetes, is nothing but this is the orchestration engine or open source platform for managing containerized applications. We can handle multiple Dockers. We can handle multiple containers. So that case we go for Kubernetes. Now we'll see what is the main features. See here automated scheduling, say Kubernetes provides advanced schedule to launch container on cluster nodes. So as of now just what is what, it is following master and worker node architecture, and so there is schedule concept, which worker node you want to deploy, where you want to deploy and where you want to execute. So that and all we can automated scheduling concept, and also self healing capabilities. Right, what is self healing? Self healing means rescheduling, replacing and restarting the containers which died. Suppose already I told, right, if one container is died, this is not working, this is crashed, deleted someone, what it will do? Automatically it will create, what it will do? Automatically it will create one more container. Now got it? For example, unfortunately this container crashed. Unfortunately this is a crashed. It is not working. This is died. So if it is died means it is down state, right? Your application downtime. I don't want my application downtime. Always keep my application live. So is it possible to with the help of container? No. Manually we have to run it. I don't want manual. Always I want to keep it my application live state. So now there is a automatically it will create one more container. No need to do manually. No need to do manually. This is the self healing. I hope you got it right. See here self healing probably see capabilities. Rescheduling, replacing, restarting containers which died. So first priority is it is scheduling at replacing or restarting, and if it is died really automatically it will replace one more container. That's it. Now see here automated rollout and rollback. Now, if Docker, so in Docker, suppose this is deleted. or this is not working, this particular version. So can you roll back to previous version? Already we have image, right? We are maintaining in Docker for every, we are maintaining one image, right? Correct.
Yes, sir.
So tag, we are maintaining here name convention is tag, image
Tag.
name,
Tag.
correct, image name and tag name. Suppose this particular tag version not working, and we are move on to so older version tag, correct. So this is the image name, and we are maintaining so tag. So tag is
Tag name.
nothing but which version. So for example v1 v2 like this, we are following some naming versioning. So for example I deployed version 2. So unfortunately this version 2 is not working properly. What we'll do, we'll delete this one. We are again we are creating with the help of version 1. Same concept here. This is the rollout and rollback. So in Kubernetes, it is following. This is very, very automated rollout and rollback. See here, Kubernetes support rollouts and rollback for the desired state for the containers application. So whatever you want, we can desire state. Which state you want? Okay. So we can easily roll out, roll back. Right, roll back. If particular version is not working, if particular, for example, V2 version is not working, I want to roll back to V1. That's it. Suppose this is also I don't want, we can go for V0. So this is the easily we can handle versioning. That is the rollout. Now see here horizontal scale and load balancer. So in AWS also there is one concept load balancer. So load balancer is nothing but distributed your incoming request to multiple instances, AWS instances or AWS resource. For example, I have three servers. Now assume. So you have anyway, sir will explain in AWS. So there is one concept. What is this concept? Load balancer. So this is the one server. This is the one server. So this is the one server. I have three servers. So in all servers, application is running same application. So they just assume these are the three servers. These are the why it always change to older. Now see here. This is the one server. Okay, and this is the another server. This is the server 2. Now my application is deployed three servers. Now if you send any request, if you send any request, the request goes to which server? I am the user. I am the end user. I am the end user. I am sending one request. The request goes to which server? Whether it will go to this server or whether it will go to this server or whether it will go to this server. We are maintaining load balancing. I don't want to give burden to only particular server. Now clear guys? So this is a very,
Yes.
very important concept in AWS also. Anyway, sir will explain what is AWS. So what is load balancer? Simply if you want to understand, distribute your incoming request to multiple AWS resources or multiple servers. Okay. Even what is a load balancer? Load balancer. If you say here, see here, load balancer efficient to distribute incoming network traffic across group of backend servers. So we have multiple servers. See here, balancing the process of distributing set of tasks over the set of resources. Now got it? So this is very simple. Load balance is nothing but distributing your incoming request to distribute the traffic, network traffic equally across pool of resources that support an application. So I want to distribute my incoming request to multiple servers, network traffic. I don't want to send every time my request to same server. Okay, so for example, this server is load, heavy load. So automatically request distribute to this server. This server also heavy load. Automatically request go to this server. That's it. Very simple. I hope you got it right. Clear? Anyway, this is very,
Yeah,
very
got it.
important. Okay.
Yeah.
Now if you go to here, same. See here, this is the horizontal scaling and load balancer. Kubernetes can scale up and scale down as the application as for requirement. So if you want to, we can scale up. Scale up means increase the servers. If you don't want,
Yes,
we
sir.
can decrease that servers also. For example, if you go Flipkart, right? I hope everyone know what is Flipkart. Now, so Flipkart, just assume, so they have one server maintenance. This server can handle 1,000 requests. Just assume this is a Flipkart server, and this server can handle 20 or 5,000 requests at a time. How many requests it will handle? 5,000 requests. 5,000 requests at a time. This server can handle. But if you come to festival season, right? Festival season means many people they are hitting the same server, correct? Yes or no? So festival season, so many users they are hitting same server.
Yes, sir.
Suppose if you get more than 5,000 requests, so this server can handle? No, right? So automatically I want to scale up one more server. I need to create one more server. Same setup, same configuration. Now request go to this server. That's it. The festival means so we are giving only 10 to 15 days, right? Offers 10 days or 1 week based on their based on festival. We are giving some offers. So once everything done, I don't want this server. No need to pay amount, right? Now we are maintaining two servers. Okay. Now normal days. So normal days again my request coming only 3,000 to 4,000 request. Now why you need to maintain this server? Again I need to scale down also. I don't want this server. I want to remove this server. So if you want to handle, there is a this is the scale up. See here we can easily scale up and also we can easily scale down your application. So these are the main features of Kubernetes. Just remember whatever you understand. Interview purpose also very important. So most of the people they are asking, okay, so what is Kubernetes and so what is the advantage? What are the features of Kubernetes? If anyone is asking, just automated rescheduling, self-healing capabilities, and automated allocates, rollout and rollback, and horizontal scaling and load balancer. So this and all. These are the some major advantages. See here features. Automated scheduling. Kubernetes provide advanced scheduler to launch containers to cluster nodes based on their resource. We'll see one by one what is cluster nodes and all. Now see here self-healing capabilities. Kubernetes allows to create, replaces and reschedule the containers when nodes is die. So it also kills container that don't respond to user defined health checkup and automated rollout rollback. If you want to, we can roll out. If you want to, we can roll down, scroll down also. Okay. So these are now anyone any doubt guys as of now automated and horizontal scaling. We will see practically all these concepts how it will work. So these are the orally I am explaining. This is orally I am explaining. Just try to understand. So these are the some of the features. Not only these features, there is many features available in Kubernetes. So that is the greatness of Kubernetes. And with the help of we can now see here and service discovery and load balancer. And we can maintain load balancer. So with Kubernetes, there is no need to worry about networking and no need to worry about communication between all right nodes and all. So Kubernetes itself, they are giving one concept, network concept, with the help of all containers. Right? In Docker, how these containers communicate each other, guys? Just assume this is the one container, Docker. This is the Docker container. Okay. So this is the Docker container, and this is one more container. How these are connecting, guys? Sorry. Now understand
Yeah.
how
With the
these
help
are
of Docker.
communicate each other.
Yeah, yeah. With the help of
Docker
Docker
network.
image.
Docker network.
Yeah.
No, we created two containers.
Yeah.
Just assume we container two containers. Okay, this is a container 2 and this is a container 1. How these two container communicate each other?
Docker networks. Docker
Docker
network.
network. So there is a different types of networks available, right? Right? Bridge network. By default, which network?
Bridge network. Bridge
Bridge
network.
network, host network, none
Host
network,
non-network.
custom network. Very important interval also. So how these two containers communicate each other? By default, if you are not if you are not configure anything, by default this container connecting each other with the help of bridge network. If you want to, we can give host network. Host network we can give only one container. Custom network. In real time, they are maintaining custom network. They are creating their own network, own IP. They are assigning that network to a particular container. You know, right, how to create a network and how to attach it. Same concept here also. Okay, so Docker network Docker network create, and we are giving network name. And if you want to, we can give IP address. I hope you know, right, some idea. Same concept here
Yes, sir.
also. How these are here Kubernetes also it is giving some concept. Okay, so this is the Docker network. Okay, so with the help of networking, we don't see here. No need to worry about networking communication because Kubernetes will automatically assign IP address to containers and assign single DNS name for set of containers and also load balancer traffic inside the cluster. Everything taken care by Kubernetes. You don't worry. And also storage orchestration. You know, right? In Docker, which concept we are using storage purpose? Which concept we are using for I want to maintain piece of information.
Volume, Docker volumes.
Yes, Docker volume, right? So if you
Yeah,
go to Kubernetes, so there is a one more concept. There is a one more concept. PV and PVC.
PVC.
PV and PVC. Very very important.
Yeah, that is in Docker, no? PVC.
Not Docker. Kubernetes. Volume is Docker.
Yeah. Okay.
Volume concept in
PVC.
Docker.
Yeah.
Okay, but if you come to Kubernetes,
PVC.
PVC.
Persistent
Persistent volume.
volume. Persistent
Same
volume
concept.
claim. Okay.
Persistent volume claim.
Okay.
PVC. Very very important. Same concept. But there is we are giving some piece of we are storing some piece of information, but if we come to here we are maintaining data. Okay, we are maintaining data. Okay, we'll see coming classes. So these are the very very important storage orchestration and so Kubernetes orchestration. This is very 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 important. So can you explain Kubernetes architecture and how it will work? Already I told, right? So how what is the Kubernetes, what is the main components in Kubernetes? So interview also most of the people they are asking this question, very very important, very very important, just very very important. And so now just remember in Docker, you know, right? So Docker client, Docker daemon, images, containers, registries, right? Those are the major components in Docker. But if you come to Kubernetes, so these are the major components. These are the Docker architecture, sorry, Kubernetes architecture. So it is following master and worker node architecture. Already you know, right? Master and worker node architecture. Now got it. So now see here, this is the master, guys. Now if you go here, Kubernetes implements a cluster computing background. Everything works from the Kubernetes cluster. A cluster is hosted by one node acting as a master. This is also one server, and this server we are make it as master. For example, if you go real time, managers, team lead, resources, we are working developers, right? All are employer only, but only one guy manager, one guy team leader, remainder are workers, right? Same thing. Here also, this is the Kubernetes master. Now, these are the worker nodes. These are the worker nodes. Now, we need to understand, if you understand this architecture, this is very, very easy. We can easily understand also. We can easily understand also. See here, this is the user interface. This is a Kubernetes master. This is a worker node. This is a worker node. So like this, we can configure many worker nodes. Okay. Now, if we come to master, so there is majorly main four components. This is the master, and we can create multiple worker nodes. Whatever we want, we can create. So this is acting as master, and these two are worker nodes. So this is acting as master. These are the worker nodes. So these are the worker nodes. These are the worker nodes. Now see here. Now see here. Now got it. This is the master. This is the master. I don't know why it is every time it is changing font size. Is there any option fix it? Anyone any idea? Every time it is go to 11. I don't want
Yes,
11.
sir.
I
Like
want to set 20 or 18. Is there any option? Okay. Okay. So this is, if you come to master, there is ECTD. These are the main components. So these are the main components. So these are the main components. And where is this? Text. Okay. So these are the main components. One is ETC.
Again 11, 1 to 11.
Mhm. So it is coming. So these are the ETCD. ETCD and so Kubernetes API. These are the main components. Same. This is the ETCD Kubernetes API, that is API server, scheduler, controller. Now, these are the main components. So we need to remember API server, API server. This is the first one. And so not only order, we can next scheduler, ETCD, ETCD. Next scheduler, schedule, scheduler. Next, this is the controller. This is the controller. This is the controller. Okay. Now this is the master, right? Master is nothing. This is also on server. Don't confuse here. This is the master server, Kubernetes master, and these are the worker nodes. Just assume this is the node one, worker node one or node one. Both are same only. Sometimes I am calling worker node. Sometimes I am calling node only. Both are same only. This is the node two. This is the node two. Now, if any request come to end user, now see here, we can connect master two ways. One is UI and one is CLI. These are the user interface. So these are the user interface. So we can connect master two ways. The first way we can connect UI, user interface, or we can connect via CLI. Clear guys? Command line interface. Whatever you want, we can connect. Both are same purpose only. Both are same purpose only. So we can connect via UI or we can connect via CLI. I hope you got it right. Now this is the master. This is the Kubernetes master. In master we have four components: API server, ETCD, scheduler, controller. We will see one by one later and we can easily understand. Now, if you want to connect master, how many ways we can connect guys? Two ways. How many ways we can connect? Two ways. Whether we can connect a CUI or whether we connect a GUI, that is CLI, user interface. This is the UI. UI means user interface. This is the UI, user interface, like the front end. This is the UI. Or we can connect via CLI, command line interface, via command line interface, CLI. This is the command line interface. So for example, I am the end user. I am the end user. Just assume end. I am the end user. If we send any request, if I send any request, first the request go to master. In master, we have four components. So API server, etcd, scheduler, controller. If you go any office, there is a front desk, right? Yes or no?
Yes, sir.
Okay, same like API server is the front desk, like front desk. If you send any request, if you send any request, first the request go to API server. The first request go to API server. The first request go to API server. Who will receive? See here, there is for API server. Cube API server is interact with the API and it is front end of the your Kubernetes control plane. It is acting like a front end. And a communication center for developers, system administrators, other Kubernetes components. I hope you got it right. Even if I send any request, I am sending one request or CLI mode also, whatever it may be. So the request first go to whom? API server. Who will receive your request? API server. API server is acting as front desk. API server is acting like front. See control panel. This is the front end. This is the front end of Kubernetes control panel. Communicate center for developers or system administrators or other Kubernetes components. This is very, very important. If we send any request, first the request go to whom? Who will receive that
Master.
request? API server. For example, I am entering my username password, or for example, I need something. If I send any request, the request go to API server. In Docker also, you know, right? Docker client. In Docker client is nothing but a user. If you send any request, that first the request received by Docker daemon. Docker daemon knows. what do you want? Whether you want containers, whether you want images, what do you want, right? Yes or
Yes,
no?
sir.
Same concept here also. If you send any request, their Docker client here UI or CLI. If you send any request, first the request go to API server. API server read your request. For example, you go to office interview purpose. First you go and write enter information. You fill some form, right? For which purpose you came, whom do you want to meet, what purpose. They are asking some basic information. Once they noted, next they will send it to that particular room, interview room, or whom do you want to connect. Same concept here also. Now you send one request, the request go to API server. API server read your request. Now this information it is stored into the etcd. This information it is stored into the etcd. See here, etcd is the simple distributed key and value store. You know, right? What is key and, for example, user name I am giving, for example, DevOps. Here which is the key, which is the value, guys? This is the key, this is the
Key,
value.
the value.
uh, so this API server store this entire information in etcd. In etcd, which format it is storing? Key and value format. Which format it is storing? Key and value. See here, etcd is the simple distributed key store values. Kubernetes uses etcd as a database. It is using like database. It store all cluster data. Some of data stored in the etcd: job scheduling information, parts information, state information, and whatever you want. Whatever you want you send, that information and all it is stored into the key and value, format. It in the Kubernetes uses etcd. Okay, this is a simple database. It store all cluster database. It store all cluster database. It will store our cluster database. I hope you got it. Anyone any doubt here?
No, sir.
Very very important. Now these 2 points clear. Now what is scheduler, what is controller, we'll see. Now see here, what is scheduler. Now see here, now scheduler watches the pods and assign the pods to run on specific host mission. Now if you go here, so this is the node, here 4 components. If you go to worker node, every worker node have these many components. See here, so there is a kubelet, proxy, docker, pods. These are the major components in worker node, every worker node, not only one. So what are those? Pod, next docker, next kubelet, next proxy. These are the proxy major components. Proxy, every worker node, not only single this one. Suppose we created 10 worker nodes, every worker node has same. I hope you got it right. Anyone any
Yeah.
doubt?
No.
Same worker nodes. Okay, same, all worker nodes have same components. Every worker node has pod, docker, kubelet, proxy. Now observe here, kubelet, proxy, docker, pods. We can create multiple pods. So every pod, each pod has container. So whether it is a single container pod or multi container pod, we'll see later. So for the time being, just try to understand new words, terminology. Try to digest new words. If you know these words, we can easily understand. Without this terminology, we cannot understand the Kubernetes. So now next 1 week or 10 days, I am going to explain. I am going to keep on saying these words only. Pod, Docker, kubelet, proxy, API server, scheduler, controller, etc. Clear? Now we have
Yeah,
some
clear.
idea. So what are the main components in master and what are the main components in node, worker node? Now we know what is API server. Now we know what is etcd. Now let's see what is scheduler. So what scheduler? See here, scheduler. Now what scheduler will do? See here, scheduler. Scheduler watches the parts. So we have parts, right? So where is parts, guys? Master or worker node? Parts are available master or worker node?
Worker node.
Only worker node. Don't don't confuse here. This is the master. In master, we have only main four components. So these are the worker nodes. Every worker node has parts, multiple parts, whether it is single part or multiple parts. And also each part has Docker, kubelet and kubeproxy. Clear?
Yeah.
Okay. Now if you come to here, see here, scheduler watches the parts and assign the parts to run on which specific host machine. Now what scheduler will do? Scheduler keep on watches parts. Suppose you created one pod. Suppose I created one pod. Which worker node you want to run, guys? That and all taking care by scheduler. I hope you got it right. So now we created one pod.
Yeah.
For example, I created one pod. So I created one pod. I created one pod. This pod in which worker node we have to run. Whether you have to run this worker node or whether we have to run worker node 2. So this and all taking care by scheduler. Scheduler
Sure.
watches the parts and assign parts to run on specific node machine, specific host machine. That is nothing but worker node. Clear?
Yeah. Yeah.
Very, very important. Enter purpose. 99% people are asking. So can you explain Kubernetes architecture? So what are the main components? What are the main components in Kubernetes? What is the Kubernetes architecture and all? Now let's see last one, controller. What is controller? Controller manages, runs the controller background, which runs different task Kubernetes cluster. So controller means like manager. Controller means like manager. See here, it is managing. And so task, which task, who are working. Manager what will do? Manager keep on monitoring, keep on watching, who are working which task. అంటే ఎవరెవరు ఏ టాస్క్ వర్క్ చేస్తున్నారు, ఏ ప్రాజెక్ట్ వర్క్ చేస్తున్నాడు. సో ఇవన్నీ మానిటరింగ్ చేస్తూ ఉంటాడు. సేమ్ కాన్సెప్ట్ హియర్ ఆల్సో. కంట్రోలర్, it is running multiple tasks, different tasks in Kubernetes cluster, and performs cluster level functions, that is replication and keeping track of worker nodes, handling so nodes failure. So what are the replication and what is how many worker nodes are running and how many it is nodes are failing, how many nodes are working fine. This and all controlled, and there is many controllers available. So there is node controller, replication controller, endpoint controller, replication set controller, deployment controller, demand set controller, job controller. There is lot of controllers available. Each controller it is taking care by one part. Now see here, what is node controller? Node controller means it responsible for noticing and responding when node is go down and when node is go up. So nodes మొత్తాన్ని హ్యాండిల్ చేసేది ఎవరు? నోడ్ కంట్రోలర్. So
Not
here how
controller.
many nodes we have? Two nodes. Whether
Two
these
nodes.
two nodes are working or not. Whether these two node, one node is failed or this node is not working properly. So who is handling? Who is handling? Who is handling? Node controller. There is replication controller. It maintains the number of parts. How many parts you want? So there is a part, right? How many parts you want? Each worker node. Whether only one part or multiple parts, these and all controlled by replication controller. And endpoint controller. See, join services and parts together. So this is the one part, and we have multiple parts. How these parts are working, how these parts are can communicate each other. This and all taking care by endpoint controller. Sorry, replication set. See here, parts running in all time. Whether these all parts are running or not. Monitoring replication controller. Deployment controller. Declarative updates for parts and replica sets and demand sets. And it is maintaining one copy. See here, controller ensures all nodes run one copy of specific node. So I want to maintain every worker node. I want to create one pod. That is common pod. So that is the demand set. Next, jobs controller is the supervisor process for pods carrying out batch jobs. Okay, this is the job controller. There is many controllers. We will see later one by one. So there is a node controller, replication controller, endpoint controller, replica set controller, demand deployment controller, demand set controller, job controller. But every each controller it is handling specific task. Each controller it is handling specific task. Clear? Coming classes we'll see. We can easily understand. So for the time being, just try to understand only naming convention. So don't think more, and we are confusing. Okay. So now if you see here, what is Kubernetes architecture? It is following master and worker node architecture. It is following master and worker node architecture. So this is the main point. Now what are the main components in master? API server, scheduler, control manager, etcd. And
ETC.
what are the main components in worker nodes? So pods,
Pure
Docker,
dark.
kubelet, kubeproxy. That's it. Don't think more. Now we have some basic idea. What API server? What is the responsibility of API server? What is scheduler? What scheduler will do? What is etcd? What is control manager? I hope clear, guys. Anyone any doubt here still?
Yeah, clear.
Okay. So next class I will explain. So these components. This is very very important. If you understand at least basics, we can easily understand Kubernetes. Otherwise, this is very difficult. How it is work? So which components it is taking a particular task. Okay. So these are the main components. First, try to remember, try to digest. These are the new terminology, right? So first, try to remember these words: API server, scheduler, control manager, etcd, and these are the kubelet, kubeproxy, Docker parts. Here four. Now we have some idea these four. Next class we'll see what is this and all. Okay.
Yeah.
So that's it from my side today. So this is theoretical, right? It is boring. Okay. So next class we'll see